which is fine. Okay, lovely. Welcome everyone to the introduction to oil beetles with the Life on the Edge project. My name's Hayley Herridge and I'm the conservation officer on the project, and I work for Bug Life. This is going to be a brief introduction to Life on the Edge. This project is a landscape scale project that aims to restore resilient populations of some of the UK's most threatened invertebrates and plants living along the South Devon coast. We're focusing on 26 rare invertebrate species and a large number of Devon special plants across 5 distinct hotspot areas, engaging people with nature across the whole of South Devon. This includes the last known population of the Six-banded Nomad Bee, Nomadus exfasciata, a bee which faces imminent extinction if action is not taken. So to save these species and provide them with a long-term future, we'll be working to create a connected network of wildflower-rich habitat or bee lines that will enable species to move freely, expand populations and recolonize areas where they have been lost across the landscape. This mission requires collaboration and support of the whole community, from landowners, farmers, parish councils, groups and individuals. South Devon Area of Outstanding Natural Beauty lead on the project in partnership with Bug Life as a key delivery partner, as well as the National Trust, Torbay Coast and Countryside Trust and the South West Coast Path. The project has currently been funded by the National Lottery Heritage Fund, the Devon Environment Foundation and Milky Wire. And we're in an 18-month delivery phase, which basically means we're in the process of laying down the foundations of the project for delivery. Our second round application will go in August 23, and the actual delivery of the project will run from April 2024 to 2029. We're working with a host of other partners as well, not all of which I can mention tonight, but just to touch on a few, there's a couple of other wildlife NGOs, including Devon Wildlife Trust and Plant Life, and then some more community focused organisations and groups such as Dementia Friendly Parishes and Devon Young Carers. So there was a couple of significant pieces of work that took place prior to this project and that sort of brought about the idea for the project. In 2017, the Devon Local Nature Partnership updated the priority species list for Devon, which was around circa 1,600 species of priority for Devon. This was then shorted to 96, of which Devon had a responsibility for, and this list is known as the Devon Special Species. This piece of work also found that that South Devon has the highest concentration of rare and threatened species of anywhere in Devon, and most of these are invertebrates, and for some species South Devon is the national stronghold. So with this, alongside the South Devon Bee Lines work, this created the concept of a species-led conservation land management project. For those of you who may not be aware, Bee Lines is a national initiative that aims to restore wildflower-rich habitat on a landscape scale. The B stands for biodiversity, and on this map here you can see the bee lines highlighted in red. They're 3-kilometre wide insect superhighways or corridors that have been mapped for South Hams as well as the whole of the UK, and they act as a bit of a blueprint for grassland restoration, addressing habitat fragmentation and connecting up bigger and better habitat. These bee lines also overlap sites of special scientific interest and important plant and invertebrate areas, which will help to connect these, and the bee lines will help to connect these special areas of high concentrations of species. The focal area of the project spans over 75 kilometres from Wembury to Berry Head, and within that we have 5 hotspots, which you can see here highlighted in blue within the coastal bee line, and these are where the greatest concentrations of special species can be found. So why have these special species been pushed to the edge? If we take a look at land management change or in terms of a coastal context, since the mechanization of farming, accessible cliff tops have become intensively farmed, including use of pesticides, resulting in species that once thrived being pushed to the coastal edge where semi-natural habitat remains. Declines in extensive grazing of hardy livestock has encouraged scrub encroachment and has resulted in the loss of many rare plants and their associated invertebrates. But things are changing. Why so many rare species down in South Devon? Well, I think it's the quality and the long-term continuity of habitat found here, which has enabled species to persist, albeit hanging on in some cases, when they have been lost from elsewhere in the county or the country. We have a combination of soft rock cliffs, making fantastic nesting habitats for bees and wasps that you can see here in this photograph, hard rock and rock outcrops, heath and grassland scrub mosaics, and wildflower-rich clifftop grasslands, including the Torbay limestone grasslands, which are very significant, natural springs and seepages, and low-input arable. So I'm not going to talk you through all our species, which is a bit of a shame because it's fascinating and it's the bit I enjoy most. But as I've got limited time tonight, just to mention a few, we've got the dotted bee fly, black mining bee, water droplet mining bee, the Mediterranean Oil Beetle, which John's going to talk to us about tonight, and importantly, the Six-banded Nomad Bee, which is at imminent extinction, at risk of extinction if action is not taken, and its host species, the longhorn bee. We also have other invertebrate groups, including Lepidopterus. So we have an example here, silver-studded blue. We have hornet robberfly, grey bush cricket, and the moon spider. It's not just invertebrates, though. We're looking at across taxa. We're also working in partnership very closely with Plant Life and Andy Byfield, the local leading authority on many things, including coastal grasslands and heath. He's been reviewing a long list of 105 vascular plants that make up the South Devon plant species assemblage, 72 of which exist in our hotspots. And he's been looking at the distribution of those, the health of those populations and their ecological requirements, all of which he's feeding back to us during this development phase, which will go into our conservation action plans. We have two species here as examples, bloody cranesbill on the left, which you can see along Prawl Point, and Autumn Squill, which you can see in quite large numbers at Berry Head. So what's going to be happening during delivery? We are going to aim to restore resilient populations of rare and threatened species through the restoration and creation of species-rich grassland on a landscape scale. And we'll be focusing on building a local seed bank through the creation of species-rich donor sites and providing equipment for people to harvest seed to support future restoration. We're going to be working closely with landowners to improve management of cliffs and slopes, including grassland scrub mosaic and heathland. We'll be looking at altering grazing regimes and installing water supplies and fencing to support beneficial management. Plus, we'll also be looking at species-specific work. We'll also be supporting landowners in enabling them to carry out this good work for our special species through entering agri-environment schemes and the transition into the environmental land management scheme. And we'll be creating a network of local meadow makers as well to support smaller scale meadow work and create a bit of a community around that. There'll also be plenty of habitats and species monitoring, and last but most significantly, working with landowners to prevent the extinction of the six-banded nomad bee. Now, Life on the Edge is a real people project, and we want to support people in reconnecting to the wildlife on their doorsteps. So we'll be working closely with local communities, both rural and urban, and visitors to South Devon to connect with the special wildlife on their doorstep. We'll be developing a digital toolkit with online learning and resources, using the arts to build awareness and to celebrate species, working closely with people such as Doorstep Arts and other facilitators. We'll be creating opportunities for some of our target audiences, such as older and more isolated people, to connect with Devon's special heritage and improve health and well-being. And finally, we're going to be providing an activity programme for young carers and young people with additional needs. We also, importantly, want to empower people to contribute to nature's recovery. We're going to be providing all sorts of training opportunities, training for 20 apprentices, training for volunteers and landowners and community groups to help build skills to maintain the right conditions for species long term. We'll be supporting people to take action through citizen science and events and practical conservation, and working with communities to create pollinator plans for parishes and maybe a larger scale as well. We'll also be providing some small capital grants for community groups to create pollinator habitats, and working very closely with the South West Coast Path and tourist providers to reach our visitor audiences in Devon. So very quickly, I just want to touch on the development phase, which is what we're working on now. It's an important time in the partnership just to lay the foundations, as I said before, for 2024 and prepare for the next application. We're busy building partnerships, capturing baseline data, preparing delivery action plans for conservation and community engagement, working with advisors on developing the project, trialling events and training and evaluation tools, and meeting with landowners to make plans for special species and support in accessing grants. On the community engagement front, we're also working very closely with consultants to build our community contacts and develop a suite of project activities, doing some planned work to work with our target audiences and putting on some family events, trialing various different things out. And finally, we'll be creating a schools resource pack for use during delivery and trialing the beginnings of the arts programme. Okay, so if you have any questions, please feel free to put them in the chat, and I think we'll address those at the end of the workshop. Okay, so now, John, if you would like to share your screen and carry on. Thank you.
Thanks very much, Hayley. I'll just start my presentation. I need to share the screen first. So hopefully, does that look all right, Hayley?
I can't. Yeah, you haven't shared anything at the moment, John.
All right, hold on a sec. I'll just escape out of this. So I'm sharing that, share, and then play. So is that better?
Yeah, that's better. It's not full screen yet. There we go. That's perfect.
Okay, cool. Right.
Oh, no, it's gone. Sorry, John. Oh,
what's happened?
It just flicked back, but no, that's full screen again, so you're good to go.
Okay, fine. Yeah. Okay. Yeah, sorry about that. Sort of technical things over. Right. Okay. Well, thanks very much, Hayley, for the intro, and thanks for everyone for tuning in this evening to listen to this talk on British oil beetles. The talk will last about 3/4 of an hour, and there will be an opportunity to ask any questions, and I'll happy to answer those at the end. So if you have any questions, just type them into the chat for the moment.
Thanks. I might just go and quickly draw some soaps.
Okay, so it's there when you're ready.
Right. Okay, right. So brief introduction to myself. I've been interested in natural history all my life, and I'm lucky to be able to do this as my work, as well as pleasure. I'm interested in all sorts of wildlife. So there's just a few things that I've studied over the years. So apart from oil beetles, which I'll be talking about this evening, things like adders, frogs, lots of bees, cuckoos, the horrid ground weaver spider, potter wasps, and roosting long-tailed tits, all sorts of things. I've got a very wide interest in natural history. But as I said, this evening I'm going to be talking to you about oil beetles. And I very distinctly remember the first time I saw an oil beetle. I was out walking when I was at college down in Falmouth. I was out at Kynance Cove, and I came across this beetle wandering across the path. And I picked it up, and it sort of curled its legs up and pretended to be dead and exuded this oil from its knee joints. And so it looked a fascinating creature. So I read up a bit about it. But at that point, I didn't realize how much time I would devote to actually watching these beetles in the future. They're called oil beetles. As I said, they exude this oil from their knee joints. The oil is quite toxic. In America, these beetles are called blister beetles. But I think the ones here don't seem to actually cause any irritation to my skin. Well, certainly I've never had any problems touching them. But if you have got sensitive skin, do be aware of this fact that this is quite toxic, this chemical that's produced. And this enables oil beetles to walk around quite brazenly during the daytime because they are distasteful to birds and other invertebrates as well, which may predate them. As is this case, if there's one of the colonies of oil beetles I watch, one of the populations is in an area where there's lots of wood ants, and the wood ants will attack the oil beetles, but after a few minutes they give up because they get a taste of this nasty toxic substance, and they give up and leave the oil beetles alone. No doubt birds and small mammals will do the same thing. But the oil beetles do attract some insects. So often when you're watching them, particularly the violet and black oil beetles, which are out in the spring, they'll attract tiny little midges. And these actually feed on the oil beetles' oil. And they use this, sort of incorporate these toxins into their body as a chemical defense for themselves. This is usually get one or two. This is an extreme case. This is one beetle I found up on Dartmoor at up near Ventford Reservoir in the woods there, and it was actually covered in these little midges. And also cardinal beetles if they find an oil beetle, they will jump on it and suck some of that chemical out as well. And again, they're using it to reinforce their own chemical defense system. So oil beetles, as I'll be talking about the identification of oil beetles and the ecology during the talk, oil beetles can be confused with, they're pretty distinctive, but they can be confused with a few other species which are commonly encountered. And these are just a few of the more obvious ones that tend to come up more times than most. So the bloody-nosed beetle, which inhabits the same sort of coastal habitats as the black oil beetle, and also some of the other habitats where the violet oil beetle lives as well. It comes out at the same time of year, and it's quite a large, conspicuous beetle, but it has wing cases which cover the whole of its body. It's quite big, flat feet, sort of padded feet, and it's on closer inspection, it's quite different from the oil beetles, as I will show you in a minute. This leaf beetle, Galaruca, is superficially quite similar to an oil beetle, particularly the female with her extended body, but her wing cases do not overlap and they're not splayed apart as they are in oil beetles. So that's a feature for that one. The violet oil beetle type of ground beetle, again, it's a big, colourful, violet-coloured beetle, but it is actually quite different to the oil beetles. Its wing cases cover the whole of its abdomen. And the devil's coach horse, which has short wing cases, but it's quite a different shape to the oil beetles. It has quite a long body, and if disturbed, it will rear up its tail and protrude these sort of white organs from the end of it and look quite aggressive. So it is actually superficially similar, but fairly easy to distinguish. So these are the British oil beetles. There are currently 5 in the genus Meloe, which are found in the UK. There are 3 other species which are presumed extinct, but they may not be. It's sometimes difficult to prove things are extinct, but they haven't been seen for a long time. So we have the black oil beetle on the top left, the violet oil beetle, and these are quite large species. And I'll talk about those first, and they're the actually most common and widespread ones. Then we have the rugged oil beetle and the Mediterranean oil beetle, and then the short-necked oil beetle on the bottom right there. So the ones that have become extinct are the variegated oil beetle, Meloe variegatus, autumnal oil beetle, Meloe autumnalis, and the scarred oil beetle, Cicatricosus. Now, these haven't been seen for probably about 100 years, but this doesn't mean they're necessarily extinct. They probably are, but they haven't been seen for a long time now. But the short-necked oil beetle hadn't been seen for 50 years, and the Mediterranean oil beetle hadn't been seen for about 100 years as well, until fairly recently. So some of these oil beetles may be lurking out there somewhere. It just needs more people to be aware of them and to go out and look for them. There are some other beetles in the same family, the Meloidae. This is Sitaris muralis, the flame-shouldered oil beetle. It's a similar thing, but it doesn't look quite like the Meloe ones, but it has a similar life cycle. It's associated with the hairy-footed flower bee, Anthophora plumipes. Now, the bees fly, as you probably know, fly in the springtime. This is a very early flying, quite a common bee, certainly in southern England. And it nests often in banks or holes in walls. It really likes cob walls to nest in. And that's the host for this beetle. So the beetles actually, although the bee flies in the spring, the beetles emerge in August. So if you're going to go and look for this beetle, you need to search sites where you get large aggregations of the hairy-footed flower bee, and search those in August time and see if you can find this beetle. And again, it was thought to probably be extinct as well until fairly recently, when Paul Brock found them in the New Forest. And then it's also been found near Salisbury, and I think maybe somewhere else now as well. And this is by looking at sites where the hairy-footed flower bee nests. And this is one of the sites near Salisbury. So it's a cob wall where there's a lot of holes there where the hairy-footed flower bees nest. And then I visited this site in August a few years ago now. And searching amongst the holes, I found this female Sitaris. They don't really do much, these things. They just crawl out of the hole where they've developed on feeding on the bee nest inside, and then they'll mate near the bee nests, the female, and then the males will die. The females will lay their eggs around the area where the bees are nesting, and then they'll die. So they don't really go very far. So you really have to go and target this beetle to try and find it. And there are some other species in the Meloidae which are found in the UK, but they are quite rare. There's the Spanish fly litter vesicatoria, which has been seen on the Isle of Wight and maybe other places on the south coast. And it could be a potential thing which could colonize. It's quite a distinctive bright green thing, and it's often found feeding on vegetation, things like privet that will be found on in the summer months. And the ivy bee blister beetle, Stenoria annalis, which is currently only found on the Channel Islands. It's quite common in France and places, down sort of west coast of France, I think down into Spain as well. And this one is a specialist on the ivy bee, which is, as you probably know, has recently colonized UK, certainly in the last 20 years. And the ivy bee has actually hopped across the channel, and it's actually escaped from its parasites. So Stenoria is left in, it's just got in France and in the Channel Islands, but hasn't made it to the UK so far. But it's a very interesting beetle, has an amazing life cycle with the triangulin larvae, which I'll talk about in a little while in our resident species. And this one in Stenoria, the triangulin larvae will actually bunch together and produce a pheromone scent, which is similar to a female ivy bee. And the males will attempt to mate with this clump of larvae. They'll get the larvae on their bodies, and then when they mate with a real female ivy bee, the larvae of this beetle will jump onto the female bee and then be taken back to the nest. But I'll explain the ecology a bit later on. There is another beetle, it's not actually in the Meloidae, in the Rififoridae, called the wasp nest beetle, Metoacus paradoxus. And this, I mean, it's not really, it's currently not classified amongst the Meloidae, but it has a very similar life history, and it may well turn out to be more closely related than is thought. And this one has a strange life cycle. Again, it lays its eggs on bits of wood, wooden sort of fences and places like that, where wasps will come and collect wood for their nest the following year. And then the larvae of this particular beetle will be crawling around on the wood, and they'll attach themselves to wasps, get taken back to the nest, and the larvae of this beetle will feed in the wasp nest, I think on the grubs of the wasp. So a fascinating thing. I've never actually seen any of these species yet, but they're ones to look out for, and look at fascinating insects. So I initially saw those beetles, way back in the early 90s down in Cornwall. And then when I moved to Devon, I live in Buckfordsley on the edge of Dartmoor in Devon, I found violet oil beetles quite commonly and black oil beetles down on the coast. And so I watched them for a number of years, and they're quite interesting things, but I didn't do any particular work on them. And then about 10 or so years ago, maybe a little bit longer now, I was asked by Andrew Whitehouse at Bug Life to conduct some research on the British oil beetles, which I jumped at the opportunity to do so. And I was helped also by Anne Halpin, who worked for Bug Life then, and Darren Mann, who's an expert on oil beetles who worked at Oxford University Museum. So they were very helpful during this project. And during the course of this, as well as field work, I produced an identification guide to oil beetles. And this is still available, I think, through the Bug Life website. And I've got a version of it on my website as well, and I'll give you details at the end of the talk on how to find that. So this explains how to identify all the British Meloe oil beetles. There's not a huge amount of literature available on oil beetles. There's a very good article in British Wildlife, I think that's from 2002. You can dig that out. So obtain a back copy of that issue. That's a very good guide to the British species of Meloe. And there's an excellent, very, very good book a German book on oil beetles, which even if you can't speak German or translate it yourself, it's full of amazing photographs and a lot of information on German oil beetles, but it includes all the species which you'll find in the UK, apart from one, the Mediterranean oil beetle, which is a bit of a specialist thing. So I'm going to go through the British oil beetles now. So this is the first one, and this is the first one that emerges in the new year. So this one will start to appear usually about the middle of February, the black oil beetle, Meloe proscarabaeus. And I usually go out looking for these about Valentine's Day, is about the sort of time when they first appear. As soon as you get a sunny day about that time of year, go out to sites where you know this beetle occurs, and you can find them just emerged, crawling out of the vegetation. It's quite a large beetle. It grows 2 or 3 centimeters long, and it's quite a distinctive thing. Unfortunately, the two commonest beetles, the black and the violet oil beetle, are probably the most tricky ones to identify in the field, which is a bit of a problem. And the names don't really help, because the black oil beetle, as you can see here, can be quite sort of violety blue color. And black as well, and the violet oil beetle can be black, and it's usually more violet colored, but there's a lot of variation between the two species, so you've got to really look at structural differences to tell them apart. As a rule though, the black oil beetle is usually black with cobalt blue legs, so it does have quite a distinctive look, and it's quite a robust insect compared to the violet oil beetle as well. But all these things are quite subtle differences really, and you really need experience of looking at a lot of specimens to get to know the differences between them. So the key feature on the black oil beetle is this feature on it's called the mesonotum. It's the area between the thorax or pronotum of the oil beetle and the wing cases of elytra. And just in between the thorax and the wing cases, there's a little section. And in the middle of that, there's a very small tooth on the black oil beetle. And I'll compare this to the violet oil beetle in a minute, which has a much larger tooth. Also, the punctures on the thorax and the head of the black oil beetle are quite deep, although there again is quite a bit of variation in this character. So the main character is looking at this small tooth, and also the back edge or the bottom edge of the thorax, which is almost straight in a black oil beetle, and it's quite indented in a violet oil beetle, which I'll show in a minute. There's a lot of size variation in the species. These are, as I'll explain a bit later, they're kleptoparasites, these beetles in solitary bee nests. So depending on the amount of food that they find in the nest, these adult size will vary. So the one on the left there has got a small one, so it obviously didn't find that much food as a larva, but it still grew into an adult. So you can get these sort of dwarf adults as well as the more normal size ones. And as you can see there, that's a classic black oil beetle. It's got quite a black body and head and body, and quite cobalt blue legs. Now, black oil beetles are fairly widely distributed across the UK, but certainly the southwest of England is a real stronghold for them, and South Devon and Cornwall coast in particular are very good areas to see them. But it also, as well as coastal habitats, it will live inland, on sort of downland and grassland. So this is a typical coastal habitat. This is at Sandy Bay near Exmouth, and here you've got the sort of slightly slumping cliffs, and you'll get black oil beetles just where those caravans are there along the top of the cliff, and they're obviously using the solitary bees which nest in this soft rock cliff habitat as a host. But as I said, they also occur inland, on downland and other areas of grassland. This is one particularly easy place to see them, which is at Cernabus, at the Cernabus Giant, at the viewpoint for the Giant, just by the car park there. There's a little patch of grass in front. And if you go there in sort of March, April time, you can't really fail to find black oil beetles there. There's dozens and dozens of them in this particular spot. Now, the violet oil beetle, as I said, is very similar to the black oil beetle, but it can be told apart by looking at the mesonotum, that section between the thorax and the wing cases. And on the violet oil beetle, as you can see, I've marked there in yellow, it has this very pronounced tooth in the middle. So that is a very distinctive feature. And also the back end of the thorax is slightly indented, so it's not entirely straight. And it's also stepped down, so it's sort of whereas the black oil beetle's thorax is completely flat, the violet oil beetle is stepped down at the base. It has a sort of indented base. So they're the key features. Once you get to know them, they are quite distinct, the two species. The violet oil beetle is slightly sort of weaker looking. It's not quite so thick-legged and robust as the black oil beetle, and it also has finer punctures on its body, on the head and thorax in particular. But as I said, they can be black. So this is a black violet oil beetle. But if you look at the thorax there, it's quite indented. That one at the base, it's stepped down, and you can just make out there it has quite a large tooth on the mesonotum as well. And again, the violet oil beetle is quite widespread, mainly in the west of the UK, and particularly in South Devon and Cornwall are real strongholds for this particular beetle. There's probably more sites in Wales than it shows there as well. It does like sort of more upland areas, or it's certainly able to live in higher altitudes than the black oil beetle. And also it lives in slightly different habitats. So this is a typical habitat on Dartmoor, where it lives in sort of woodland edge habitats, often along river valleys. But these are places where there's lots of solitary bees nesting in the sandy soil. So this is in the woodlands by the River Dart in Dartmoor. And there are other sites, though, particularly around Dartmoor, where you get both species. So occasionally both violet and black oil beetles will occur together. So this is a site, sorry. This is a site just on the eastern edge of Dartmoor in the Tean Valley, where you get both black and violet oil beetles occurring in similar numbers. Next species is the short-necked oil beetle. So the black and the violet oil beetles are the commoner species, the more likely ones you're going to encounter. The three species, following species, are much rarer, and this is the rarest of them all, which is currently known in the UK, the short-necked oil beetle. It's quite distinctive. The main features to look at on this one is its thorax again. The thorax on this beetle is much wider than it is long, so it's sort of rectangular shaped. And also the antennae of the short-necked oil beetle are quite distinctive. They're very straight, and they have they're slightly thickened towards the ends as well. It's smaller generally. There's a bit of size overlap with small individuals of the violet and black oil beetle, but it's quite a small beetle, sort of about 1.5 centimeters long at the most, and it's quite shiny as well, this beetle. But it's very rare. So it was thought to be extinct. It hadn't been seen for about 50 years until 2006, when Bob Heckford, well-known microlepidopterist, was wandering along the coast path at Bulbury Down in South Devon, and he stumbled across one of these beetles along the coast path there. And he sent it to me to confirm the identification. It was one. So this was very exciting. I'd always wondered if it would still be seen somewhere in Devon. There were quite a few old records, and in fact, it had been recorded here in the past as well, about sort of 80 odd years beforehand. So it had obviously been there all the time, but it's due to a lack of awareness or people not looking. It had been sort of overlooked for many years. Now, the amazing thing about Bob is he's had a bit of a monopoly on the short-necked oil beetle for a few years, because a few years later, after finding it at Bulbury Down, he went up to Col in the Inner Hebrides looking for micromoths up there, and he found short-necked oil beetles there at another site. This is in the Inner Hebrides, and he came across the short-necked oil beetle there. They don't sort of follow him around, but he was certainly he had this bit of luck with them, and he managed to find at that point the only 2 sites known in the UK. Since then, it's also been found in South Pembrokeshire a few years ago, and on Salisbury Plain, and also in Southwest Ireland at Cahors in Wexford, County Wexford. And there it was found. Mark Telfer was doing an insect survey there, and he found it was collected just a single specimen, a voucher specimen of a solitary bee, Colites floralis. And months later, when he was looking at the specimen, he noticed it had a tiny little triangulin larva on it, and this was the larva of Meloe brevicollis, the short-necked oil beetle, and that was the first record for Ireland. So this is the typical habitat in South Devon. And it's still, despite searching, it's still only known from one site in South Devon. It could occur elsewhere. And there are old records from Dartmoor as well, from several sites in Dartmoor. And I've searched for these, but never seen it. But it's not impossible that it does occur elsewhere. So this is Bulbury Down. There was a big fire at Bulbury Down in the summer. So it's the same view. This is about August time this year. Quite extensive amount of burning took place. There was a wildfire there for several days. And so a lot of that habitat got burnt. Luckily, the areas where the bees nest are up on the top of the cliff, although some of them were probably down there as well. And they hopefully have escaped, but we'll find out next year exactly what has happened there. And in fact, the fire may have created more habitat long-term for the solitary bees, and in turn, the oil beetles as well. So this is, again, typical habitat for them along the coast path there, where you've got this rutted track. You've got a lot of solitary bees nesting in the edges there, and the oil beetles. This oil beetle, again, like the violet and the black oil beetle, this is a spring species. So the violet and black oil beetle are out February, usually for the first black oil beetles, March for the first violet oil beetles, and again, sort of towards mid to late March for the short-necked oil beetle will appear. And then the beetles can be found right through the spring, usually until about May, sometimes early June. You can find them as well, depending on the weather during the spring. This is the site at Cahors in Ireland. So again, a different habitat, but this is similar to the habitat in the Inner Hebrides as well at Col. So it's in sand dunes here. So it's not really the exact ecology of these things isn't fully understood, but it seems to be associated with Colites floralis at these sites, in these sand dune sites, and maybe a species of Colites on Bolbury Down as well, and there's other sites that have been found in the UK, but it's very difficult to investigate and find out exactly what the hosts of these beetles are, as I'll explain later on. That is the bee. That is a known host. It's quite difficult to prove the hosts of oil beetles, as I'll explain later. But Colites floralis has been proved as a host. Now the next one is the rugged oil beetle. Now this is an unusual one. It's quite different looking. It has straight antennae. So all the black and the violet oil beetle, I forgot to mention earlier, have the males in particular have kinked antennae, and I'll explain why they have those kinked antennae a bit later. And all the rarer ones, the rarer 3 species, have straight antennae. So that's one distinguishing feature you can use. You can see the splayed antennae, which tells it from the other confusion beetle, the splayed elytra, the wing cases, which tells it from the other beetles I spoke about earlier. But the thing about the rugged oil beetle, it's quite matte black and is quite rugged and sort of rugose looking thing. It's quite small, only sort of 1 to 2 centimeters long, and it's also active at night. And it was thought to be very rare, but it in fact work which I did quite a bit of work during the Bug Life project on this species. And once we discovered that it was nocturnal, it was found to not be as rare as it was formerly thought, because there were a number of sort of daytime records of it. But in fact, if you go out looking at night during the winter months, because this beetle will start to emerge in end of September, and it's active right through the winter until early April, but it's mainly nocturnal. It seems to be associated with calcareous sites, so limestone grasslands in the Cotswolds seem to be one of the strongholds for this beetle, and also in the Mendips now it's been found. Other sites in South Wales and down on the south coast near Bridport, where it occurs again in sites which are calcareous or there are calcareous clay sites as well. There's always some sort of calcareous influence in the habitat where you find this particular beetle. This is one of the sites in the Cotswolds. This is near Stroud. So this is a very steep south-facing slope. It has a little path along here, and there's hundreds and hundreds of small solitary bees which nest here in the spring, and the rugged oil beetle obviously uses these as hosts, although it's not exactly known which species it uses. And this is a site on the coast near Bridport. So this is some calcareous clays, and the rugged oil beetle occurs here in slightly smaller numbers in scattered populations in areas like this. Is a small bit of grassland right on the base of the cliffs there, just along the coast from Bridport. But as I said, these beetles are nocturnal, so you've got to go out at night to find them, and they emerge just after dusk, and it's best to search for them on mild, sort of damp, cloudy nights, anytime sort of October. It's usually best wait for the clocks to go back, and then you don't have to stay out too late. You go out to about 5 o'clock in the evening, they'll start to emerge, and if you don't find them on a site within an hour or two, they're probably not there. They can be quite localized, where they tend to not move around so much as the violet and the black oil beetles, which can move about quite a bit during the daytime. These rugged oil beetles tend to stay around the areas where the bees nest, and so you can find often, once you find one in an area, you'll find several, and they're usually associated with paths or banks and those sort of sites where there's lots of solitary bees. And they're surprisingly easy to find by torchlight. You might think looking for a black beetle at night is tricky, but they stand out quite distinctively in the torchlight. And they are, as I said, they're quite rugose, quite easy to identify from, or certainly tell from the 3 species I've mentioned so far, by this sort of rugose matte appearance to them. And the distinctive feature of the rugged oil beetle is, again, looking at the thorax, and it has this sort of indented furrow along the middle of it, a very distinct furrow there, which tells it from the next species I'm going to talk about, the Mediterranean oil beetle. And this is the Mediterranean oil beetle. Now, this has an interesting history in the UK. It was actually found in the 1800s in Kent and Essex, and collected then, and some of the specimens ended up in the Natural History Museum, but it wasn't actually identified as a British species until the 1990s, when an Italian oil beetle expert was visiting the Natural History Museum in London, and he was looking through the series of specimens of Meloe rugosus, and he found some specimens of Meloe mediterraneus, the Mediterranean oil beetle. So at that point, it was thought to be a long extinct resident of the UK, but it is very, very similar to the rugged oil beetle. So similar, in fact, that I overlooked it for several years before I actually refound the species in the UK. And if you look at it, it's generally a bit bigger than the rugged oil beetle. So while I was doing the work for Bug Life, the rugged oil beetle, these are some sites around Stroud, so in the Cotswolds. It was known from there, so I was doing some field work at night. But it had also been found at Bulbury Down. In fact, I found it there when Bob Heckford, really quite a strange story, because when Bob Heckford first found the short-necked oil beetle, he sent me the specimen, but then he sent me a grid reference so I could go back and relocate it. But accidentally, he got one of the numbers wrong on the grid reference. So I went to a different part of the coast, a little bit further along, not too far away. And on that day, I found what turned out I thought it was a rugged oil beetle at the time, but it turned out to be the Mediterranean oil beetle. So actually, within the space of a week, the two long extinct oil beetles were found at the same site in April 2006. But as I said, I didn't really find out for several years that what I've been looking at as the rugged oil beetle on Bulbury Down was in fact a different species. And it was during the course of the field work, I was looking at the triangulin larvae, which I'll talk about a little bit in a minute. And I was looking at finding the triangulin larvae of the rugged oil beetles at various sites that were currently known. And what confused me was when I found the larvae at Bulbury Down and compared to them the ones from Dorset and also the ones from around Stroud in the Cotswolds, the larvae looked completely different. So I thought surely they're going to be a different species. So I keyed them out using a key to European oil beetle triangulins, and it was immediately apparent that the ones at Bulbury Down were in fact the Mediterranean oil beetle, Meloe mediterraneus, and the triangulin larvae, as you can see, are quite distinctive. So as I said, they're very, very similar looking, but Meloe rugosus on the left has this deep furrow down the middle of the thorax, and this is lacking in the Mediterranean oil beetle. Mediterranean oil beetle is slightly duller. So the rugged oil beetle, if you look on the wing cases there in particular, it's slightly shiny, and on the Mediterranean oil beetle, it's much more matte coloured. But again, it's quite a subtle difference. So the main way to tell the two apart is really by looking at the thorax and seeing if it has that deep furrow down the middle of it, which is lacking in the Mediterranean oil beetle. And the Mediterranean oil beetle, which is something which confused me at the time as well when I was working for it, the site at Bulbury Down was the only site which wasn't calcareous, and the beetles were much bigger. So I thought something strange was going on, but it took me a few years to work out exactly what was happening. So the Mediterranean oil beetle is a very rare species. So it's currently known from East Sussex, where some specimens, again, which have been identified as Meloe rugosus, were re-identified. And they were found just a couple of years before I found the ones at Bulbury Down. And it's also been found at Slapton Lee as well in the Field Study Centre there, just a single specimen. And it's very likely that there are other populations, certainly around southwest England, maybe in South Wales, maybe other places around the coasts of Britain and Ireland, But like the rugged oil beetle, this is a nocturnal species and it's winter active. So it sort of eludes general insect collectors or insect enthusiasts who are mainly active when it isn't really, and out in the daytime as well. So it's sort of, it comes out just as people are packing up their nets and collecting equipment in the autumn, and then dies off just as people are coming out again in the spring. So it's one thing, again, you've got to do targeted searches out at night on mild nights in the winter months to look for this thing. So this is out searching down on the south coast. So again, searching from dusk onwards by torchlight, and it's surprisingly easy to find. You can find these beetles crawling around along paths, edges of grasslands and soft rock cliffs, sort of places where there are solitary bees nesting. So these are the insects which these beetles rely on. So as I said, they're kleptoparasites. So the larvae of the oil beetles feed on the contents of the nests of solitary bees. This is Andrena hemorrhoa, a common spring flying mining bee, which is probably the host of the violet oil beetle. Although, as I'll mention in a minute, it's quite difficult to prove exactly which species are the hosts. You can do it by association, but actually proving something is a host, you've got to find the nest of the bee, dig up the nest of the bee and find an oil beetle larva inside and identify that oil beetle larva. So to prove that it's absolutely definitely the host of it. And this has been done with the Colitis floralis, which nests in sand, and it's actually quite easy to access the nests. But as I'll talk about in a minute, it's not easy to access the nests of these, and even find the nests of these other spring flying Andrena mining bees. So the sort of places that you're going to find, particularly black and violet oil beetles, are flower-rich sites. So lots of spring flowers, lots of dandelions, things like violets, bluebells, those sort of flower-rich woodland edge sites. And the violet oil beetle in particular has a 2-year life cycle. So it tends to live in sort of woodland edges and places where there's a lot of spring flowers. So the larvae can crawl up onto those flowers, and the adults as well can feed on the vegetation and lay their eggs around them. But because the beetles are living in this sort of shaded habitat, they have a 2-year life cycle. So the adults will emerge in the spring, they will lay their eggs, the females will lay their eggs in May or June, and then those eggs will overwinter until the following year, and then hatch as larvae. And in the meantime, the larvae from the previous years will go up onto the flowers and attach themselves to bees, get taken back to the nests, and then develop over the year. So with the violet oil beetle, you can find the triangling larvae and the adults at the same time in the spring, because there are 2 different generations. And when these oil beetles first emerge in the spring, their bodies, they sort of typical bodies, which are huge and bloated abdomens, are completely lacking to start with. So a very freshly emerged teneral or very newly emerged oil beetle lacks that great big body. So you can see the overlapping wing cases, but the abdomen is so small at this stage, it's hidden under the wing cases. And this is a black oil beetle. But they feed very quickly, so they'll feed up on violet and black oil beetles like lesser celandine flowers, particularly other things like cuckoo pint and various other low-growing plants, and they will gorge themselves on this vegetation in the spring. Here's one. The violet oil beetles in particular do like celandine flowers, and they'll really go for these in particular. And I have done some feeding experiments on oil beetles. These are a pair of rugged oil beetles, giving them various leaves which are found, the plants which are found in their habitat, and seeing which ones they prefer. You can see these ones really, again, buttercups are one of their favourite things to eat. If you give them buttercups, they will just demolish these. The celandine they munched a bit of, the dandelion they quite like. The rugosus didn't like the lesser celandine, whereas the violet oil beetles will eat all the lesser celandine flowers and the leaves as well. So there's a bit of variation in between what they eat, but most species seem to really go for creeping buttercups. But again, sometimes where you find the beetles, there aren't any creeping buttercups, so they'll feed on whatever's available. This is a little experiment on the Mediterranean oil beetle. So again, I gave it all sorts of various leaves to feed on, but the only one it ate was all of the creeping buttercup leaf. It ate the whole lot. And this is just in one night. And it munched a little bit of the clover, but it left everything else. And they do grow very quickly. So this is a newly emerged violet oil beetle. The oil beetles, they actually emerge underground, these things, a lot of the spring active things, and the same with the Andrena bees as well, that emerge very early in the spring. And they actually emerge as adults in the autumn, so in September, October time, but they remain underground. So the oil beetles do this as well. So they remain underground until the first warm days of spring, then they come out, emerge from the ground. And if you're out on those first days, you'll find oil beetles with these very, where the abdomen is very, very short. But this one was one of the ones I kept to study. And within 24 hours, it had eaten lots of cuckoo pints and lesser celandine leaves. And on the right there, you can see its body had expanded enormously. So they do feed on an enormous amount of vegetation. It's probably not very nutritious, so they've really got to feed on as much as possible, particularly the females. Now you can sex the oil beetles by the antennae in the black and the violet oil beetle, which I'll show you in a minute, because the males have quite kinked antennae with expanded segments along the antennae. But the best way, if you do need to, and it's not necessary to pick up oil beetles to do this, but if for any reason you do want to sex them, if you use a times 10 hand lens and look at the underside of the abdomen, the very last segment, on the male, it's got a distinct notch in it. In all the species, in the female, this notch is lacking. So that's a surefire way of telling males from females in any of the Meloe species. Now the males, as I said, the males of the black and the violet oil beetle have these expanded segments in their antennae. You can see there just towards the tips, and the antennae are quite heavily kinked as well. The females also have kinked antennae, not quite so much as the male, but they do have distinct kinks in them. So this is a good way of telling these species as well from the other species, apart from their larger size and the other features which I mentioned earlier. This is a male violet oil beetle, and he's doing what a lot of these male oil beetles do, and they climb up into the vegetation, sort of moving their heads around. And maybe they're trying to pick up a pheromone scent from the female, but they certainly seem to be scanning for something, and they climb up into the vegetation. They're certainly sort of looking around, trying to sense probably where the females are, and then they'll move and try and find the female. So you can see this is a meadow habitat, which is there's a lot of violet oil beetles in this particular meadow, which is a site which is grazed during the autumn, and then it's left during the springtime for the vegetation to grow up. Lots of solitary bees nesting there, and a very good population of violet oil beetles, and the occasional black oil beetle as well at that site. So when the females, I think as a rule, will probably only mate once. Maybe they mate more than one time. It's quite hard to tell, but the ones I've kept in captivity have just mated once. So the males will seek out the females, and then when the males of the violet and the black oil beetle, you see here's a male approaching the female, and you see the male has those very distinctive kinked antennae. The female's antennae are slightly kinked. And then the male uses these kinked antennae during the courtship of the female. So he'll actually grab the female's antennae and drag the antennae through the kink on his antennae. You see a picture here, yeah. So he grabs the female's antennae. I don't know exactly what happens here, whether it's a tactile thing or whether he's passing on a pheromone scent, but it is something which is essential for him to do before the female will allow him to mate with him. With her. So here he is again, grabbing the female's antennae with those kinks in his antennae. As I said, the males and females can vary in size, and you can get big males and quite small females. So size and the fatness of the body isn't necessarily a feature of if you find one of the great big fat bodies and necessary a female, it's worth checking the antennae. And if you in doubt, check the underside of the abdomen with a hand lens to determine whether it's a male or a female. And then if the female wants to mate, then the male will be allowed to mate, usually mounts her, and then mating lasts for about an hour. And during that time, the male is just dragged along by the female wherever she goes. You can see the female there has been feeding on the celandine flower there, and on that celandine flower there are actually the larvae of the violet oil beetles. It's a pair of violet oil beetle adults, and you can see the triangling larvae of the next generation are active as well at the same time. But if the female, once the female's mated, she'll still be approached by the males, and what she'll do, if you see females which have already been mated, they will push their antennae down on the ground so the male can't grip them with his, can't catch them with the kinks on his antennae. And then if the male is persistent, the females have another trick, which is just to walk through bits of vegetation and just get rid of the male that way. So leave him, actually sort of push him off the back, and then the female can get away and go about her business. The other oil beetles that don't have the kink in the antennae, they have a little bit of courtship, but it's not as elaborate as the violet and the black oil beetles. So they'll mate. Sometimes the male will move his palps over the back of the female's abdomen prior to mating. And again, while they're mating, which again lasts for about an hour, the male will be dragged behind the female wherever she goes. So after mating, then the female will, of the diurnal species, of the black, violet, and the short-necked oil beetles, will spend a lot of time feeding, and they will also spend a lot of time sunbathing. So this is a female sunning herself, and you see her body just gets enormous. It looks like it's going to burst. It's very, very bloated, because inside there she's developing, the eggs are developing, and the females of these larger oil beetles can lay up to 40,000 eggs, which is an amazing number for any insect. So it's one of the, it's a huge number of eggs, but they need to lay this number of eggs to enable just a handful to survive to adulthood. So the female, when she's ready to lay in, she will dig a hole in the ground, or in this case, it's an old dried up cow pat. This black oil beetle is laying her eggs in. So she'll dig a little burrow about 2 or 3 centimeters down, and then she'll back into the burrow and lay a batch of eggs inside. And each egg batch may contain 1,000 eggs. So in the case of the black oil beetle, these eggs will emerge in a few weeks after they've been laid. But as I said earlier, in the violet oil beetle, they will not emerge until the following year. The short-necked oil beetle, again, their eggs are laid in usually sort of May time, and the triangulate larvae hatch in June, July. And the rugged and the Mediterranean oil beetles, their eggs are laid during the winter months, and they'll hatch in the spring or early summer. And the triangulines are actually reasonably easy to identify. Certainly the black and the violet oil beetle, although the adults are very similar, the trianguline larvae are quite distinctive. So the violet oil beetle larvae are about just over 2.5 millimeters long, and they're black generally. You can get yellow ones, but mainly they're black. So any black or large trianguline larvae you find like this will be violet oil beetles. The black oil beetle, second from the left there, is about 1.5 millimeters long, and this one is orange colored. So it's and again it swarms around on flowers. So where you find one of these larvae is usually quite a number of them. So although they are very small, they are reasonably easy to find if you target the right flowers in the right sites. Then the rarest species have very, very tiny triangulines. So they can be just 0.5 millimeter long. So as you move to the right there, the one at the top there is with a dark head is a rugged oil beetle larva. And then below that is a Mediterranean oil beetle larva. And on the right-hand side, the dark brown larvae are the short-necked oil beetle larvae. And again, these are all about 0.5 millimeter long. There's a little ID guide, and this is available on my website. So really, if you've got a larva, if you've got a black triangulin larva about 2 millimeters long, it's a violet oil beetle. Occasionally you can get this yellow form of the larva. They have both this species and the black oil beetle have these large caudal setae, these sort of hairs that stick out at the end of their body, which the smaller species don't have, such long hairs. So that's one way of telling them apart. But if you do find a yellow larva in the sort of habitat where you think it may be a violet oil beetle, or it could potentially be a black oil beetle, if you measure them, if it's over 2 millimeters long, if it's 2 or if it's over 1.5 millimeters long, it will be a violet oil beetle, not a black oil beetle larva. And they are slightly different shape as well. The violet oil beetle larva is a little more elongated as well. As you can see, they have quite long legs, and they're called triungulins because uncus means hook, and they have 3 hooks on each foot. So this enables them to cling on to any insects which visit the flowers that they're on. Just moving across to the rarer ones. So we've got the Meloe rugosus, the rugged oil beetle is basically it's tiny, it's 0.5 millimeters long. It has a dark head and first segment of the thorax. Meloe brevicollis is brown, and Meloe mediterraneus is slightly larger than the other two, but it is a sort of orange colour. And that's some pictures of them on the flowers just below, which I showed you just now. So here they are, just to show the size of them. So violet oil beetle larvae, the black ones there, and the smaller ones are Mediterranean oil beetle larvae, just to show the size difference. So if you notice the larvae, just casually looking around, they're going to be probably violet oil beetle larvae. You've got to really look. Occasionally you see black oil beetle larvae, but you've got to really search for them. And the smaller species, you really have got to search with a magnifying glass to try and see them at all. So here are some violet oil beetle larvae. They swarm on flowers, and they can be very, very common at some of the sites, and they are quite distinctive in the springtime. Often if they're on yellow flowers like dandelions and celandines, they do stand out a mile. But they'll occur on all sorts of flowers that are in the habitat, any flowers which are likely to be visited by bees and other insects. And they'll sit on the flowers waiting for any insect to visit that flower. And so they become quite active. So one way of finding them is to actually just to touch the flowers there. And sometimes the oil beetle larvae is when you touch the flower, some sort of movement will cause them to become very active and start running around, thinking there's a potential host that's come to visit the flower. And you can see in the middle there at the bottom there is a slightly yellow form of the violet oil beetle larva. Although they all start off as yellow when they emerge in September time underground, and then they gradually turn black over the winter, and then they emerge in early spring. These are some newly emerged black oil beetles. So these would have been from eggs laid in sort of April and May time, and this is end of May, early June. And when they emerge, they often clump together, so they're not actually on flowers to start with. I don't know why they do this. In some other species, foreign species, as I mentioned earlier with the ivy bee blister beetle, these clumps of triangulins can produce a pheromone scent, which is similar to a scent of a female bee, and so attract male bees in. But I don't know if that's the case with the black oil beetle larvae, but they do this clumping. And they also occur on flowers. So along the coast path, if you look on things like Thrift at the end of May and in June, you'll find these larvae crawling around on there. And that's along a little nitigulid pollen beetle, just for size comparison. This is Meloe mediterraneus and Mediterranean oil beetle larva. Again, down on the coast path around the South Devon Coast where the beetle occurs. And these are found again in May and June, I tend to find them. They are tiny. That's a rugged oil beetle larva, just to show how tiny it is. So you really have got to target areas where you where there's a lot of solitary bees nesting, or where you know that you found the adult beetles. So this is in the Cotswolds again, near Stroud. And we know we found a lot of adult oil beetles here. So going back from there in late March, April time, and looking on the flowers, you'll find these larvae of the rugged oil beetle. And this is a technique I use, is to use a magnifying glass and then grab a clump of flowers. In this case, it was searching on Thrift, looking for Mediterranean and black oil beetle larvae. So if I grab a clump of flowers like that, any oil beetle larvae which are hidden in there will become active because of the movement, and they'll often, you'll see them running up onto the flowers, thinking there's a likely host has appeared. So that's the technique I use. And they attach themselves to any insects which visit the flower. So the females have to lay so many eggs, because so a tiny number are going to make it to adulthood because of this such a risky life cycle which they have. And you can see here, this is a little nomad bee, a cuckoo bee. And if you just look carefully on the side of her thorax, there's two black, violet, or there's another one on the back as well, violet oil beetle triangling larvae, which have, so she's visited a flower, and these larvae have immediately climbed onto her and attached themselves to the cuckoo bee. And in this case, this might be a good tactic, because the cuckoo bee female will then go to mining bee nests, and she's trying to parasitize them, kleptoparasite as well in the nests. And so the oil beetle larvae are hitching a lift that way. I don't know how these things compete with each other. So what the larva of the oil beetle larva and the larva of the nomad bee would do if they met, which one would win a fight, I don't know. And these sort of things happen underground, so they're very difficult to study, but it must happen. This is the six-banded nomad bee, which Hayley mentioned earlier. And this one was at one of the longhorn bee colonies down at around Pearl Point. And it flew into one of the longhorn bee nests, and you can see it had a lot of orange on the back of its thorax. And this was actually a whole bunch of black oil beetle triangling larvae, because this bee is active in June, and this is the time when the black oil beetle triangling larvae are around. And so this nomad bee had obviously been to a flower covered in these trianglings, and they'd hopped onto the back of the bee, hoping to get a lift to a solitary bee nest. But they'll also attach themselves to any other insects which visit the flower, such as an orange-tipped butterfly with a violet oil beetle triangling. They'll attach themselves to bumblebees, anything really that comes to the flower, even oil beetles that eat the celandine flowers, the violet oil beetle, they will get triangling larvae on them. So it's a risky life history. So the only ones that are going to survive are those which get onto solitary bees or nomad bees and get taken to a solitary bee nest. So they've got to end up in an active solitary bee nest. But they also probably use these other insects to generally disperse around the countryside, because these triangling larvae can't move otherwise. They can only walk a short distance, but they can hop onto other insects, say butterflies and bumblebees, and then get taken to other flowers, and maybe they hop off onto other flowers many miles from where they started, and then they can sit and wait for a solitary bee host there. So as well as trying to attach themselves to a potential host, which again, which I'll mention in a minute, isn't as easy as it might seem, they also can hitch a lift and just disperse around the countryside. So I have found in some colonies of, say, violet oil beetles, I found the occasional just one or two black oil beetles appear in that area. And likewise down on the coast where you mainly get, it's on the South Devon Coast where you mainly get black oil beetles, I occasionally find the odd violet oil beetle, and they've been carried there by bees. So there's not a self-sustaining population, permanent population, but you occasionally get them turning up. And I also find them in various random places, road verges and in gardens, and I get them in my garden as well, where they've come in obviously imported on the backs of bees. And this is the rugged oil beetle triangling larvae. These are on a very small halictid bee, Halictus tumulurum, that one, and they're tiny little larvae. And The size of the larvae might give some indication on what they're using as a host. But it's, as I said, it's very difficult to prove. So maybe the smaller ones are using smaller bees as hosts, but it's really not that widely known. And there's a male Andrena hemorrhoa, spring-flying orange-tailed mining bee, and that one has got that's a male, but it's got a triangular violet oil beetle triangular sat on the back of that. So if that male mates with a female mining bee, that triangular larvae would presumably hop onto the female and try and get a lift back to the nest. And this is what they're trying to get into. So this is a mining bee nest. So these are burrows down into the ground. You can they're quite hard to find sometimes, but when they're being excavated, you find these spoil heaps, little sort of volcanoes of soil, and this is an indication that there is a mining bee burrow there. But these spoil heaps often get washed away by the rain, so you've actually got to follow the bees back to the nest to find where they're nesting. And that is it's a furrow bee nest, and that's when I excavated. It just shows the ball of pollen and nectar, the bee bread, which the female bee has collected for her larvae, and there's one egg laid on that. So it's a little cell she's made in the mud underground, and provision that with this, looks like an orange, but it's a little ball of bee pollen, and she's laid an egg on that. So that's what the oil beetle larva is after. It's trying to get into a nest, and then if it can find a nest, get into access to this food supply, it can eat or destroy the host bee larva or egg and eat all its food. And then presumably it will burrow through the soil and then find other nests as well, because surely it doesn't just take one ball of pollen to make an oil beetle. It must use several of them. But there are lots of other things after solitary mining bees. So the bee fly, this is the dark-edged bee fly, the commoner one of the two. Hayley showed you the dotted bee fly earlier. It has a similar life history. So this is a kleptoparasite, a parasitoid inside solitary bee nests. In this case, the bee flies will fly around. You see them hovering around areas which are bare ground and other sites where solitary bees are likely to be nesting. And you can see them just flicking eggs, many thousands of eggs they lay, tiny eggs into areas where they think there's a good chance that bees are going to nest. And then the tiny larvae of the bee fly will crawl around, and the very few that survive are the ones that manage to find their way into a solitary bee nest. And then they find the larva, which is feeding on the bee bread, and they'll wait by that larva until it's full grown. And then when it's full grown, the larva of the fly, the maggot, will just latch onto it, suck all the insides of it out, and then that nest will produce not a solitary bee, but a bee fly the following spring. There, of course, as I mentioned before, there are nomad bees as well, which are after solitary bees. So these are cuckoo bees, so they don't make their own nests. They will actually find their host nests, and again, sneak inside, lay their eggs, and then the larva of the nomad bee will destroy the larva of the host bee and then eat all its food. But there are also other insects, like earwigs are commonly found in mining bee nests as well, and they'll go in there and eat all the pollen as well. So mining bees have got to work very, very hard, and they're also quite elusive, I think, as well, quite tricky things to find, because there are all these things after them. So it's no wonder that they're quite difficult to find. They sort of nip in and out of their burrows, so they're quite tricky for us to spot, because all these different other insects are trying to raid their nests. And as well as those, there are leucophora flies. These little flies will home in on mining bees, which are returning to their burrows, the females, and they'll follow them in or wait for the female to go in the nest and come out again. And then the fly will sneak in, lay her eggs or live maggots, which again will eat all the food that the bees collected for her own larva. And that nest will produce a bunch of these flies instead. So, as I said, it's not as simple as it may seem. It's not a case of like the oil beetle larva climbs up onto a flower, waits for insects to come along. Some of them attach themselves to a solitary bee. They get taken back to that bee nest and eat all the pollen and grow into an oil beetle. It's not as simple as that, as you probably imagine in the insect world. And I did a little experiment. This is a Andrena nitida, a common spring-flying mining bee, which occurs commonly in areas where you get the violet oil beetle, so it's almost certainly a host of it. I caught this bee as she was returning to her burrow. I put her in a little tube which contained some violet oil beetle triangulin larvae, and these, of course, immediately jumped on the bee. And then I let the bee go just to see what she would do. And she didn't fly to her nest. She just went down in the grass. She knew these triangulins were on her, and she just buzzed around in the grass and just removed all of them and then went to her burrow. So these oil beetle larvae, they've not only got to get onto a bee, they've got to hide on that bee somehow and then get taken back to the nest. And it may be the case that they just get taken to nests when these solitary bees are getting quite old and coming towards the end of their lives and a bit tired, and maybe the oil beetle larvae get onto them then and access just enough nests to keep the oil beetle population going. But again, it is not really known what happens. And that's that same Andrena nitida. So she's had all those oil beetle triangulin larvae on her, but then within a few minutes she'd removed them all by buzzing around in the grass, and then she could return to her burrow safely without risk of having oil beetle larvae in there. So she obviously knows what they are. Now, I did some mark recapture work on oil beetles, and I've marked various beetles over the years. This is the Kugelance ground beetle, another rare ground beetle which occurs in various heathland sites, including some on Dartmoor. And I could mark these by scratching a mark on the wing cases with a scalpel, and it was quite easy to individually mark the beetles. But when I tried to mark oil beetles, they've got quite a flexible exoskeleton, and it's impossible to mark them in that way. There was no way of actually putting a definite mark on them. So the only way I found in the end that I could mark an oil beetle was by just using a sharp pair of scissors and just removing the tip of one of the wing cases. So I couldn't individually mark them, but I could certainly tell which oil beetles I'd seen already, because it doesn't harm the beetle, but it immediately marks it for life by having just the tip of the wing case cut off. So there's a marked one case, and in this case I've cut both of the wing tips off. And that's a female violet oil beetle. You see she's ready to lay her eggs. She's got a very, very bloated body there. And in the area I study, just near where I live in Buttersley, just on the southern edge of Dartmoor, on any one day, if I went to the site, I may see sort of 10, maybe 20 on a good day, oil beetles, but the population was well over 100 individuals, which I found by going back there repeatedly during the spring and searching for the beetles. And I found actually that, contrary to what I first expected, was to find the beetles on sunny days. I found the best days to locate them was on sort of part sunny days in the spring when it was a bit cooler, maybe even a bit drizzly. And then the oil beetles will be out sunning themselves and be much easier to find. When it's very warm and sunny, they tend to warm up very quickly and then they'll hide away, and they're quite difficult to spot, surprisingly so. And as well as finding the adult oil beetles, I tried to find as many nests as possible, trying to decide trying to work out what were the hosts for the violet oil beetle at this site. So these are some solitary bee nests which I'd found. And I found the best way to locate solitary bee nests was to wait until, on nice sunny afternoons, wait until late afternoon, and then the bees returning to the nest would just be a bit slower. So you could sit in areas where you knew which would look likely for the bees, and you could watch the females come circling in, and then you could follow them back to their burrows and mark them. And I marked again. It was surprising how many bee nests were there. We hardly ever saw the bees, but there are again well over 100 nests that were located in that area. And then I tried to actually dig up some nests, see if I could find any violet oil beetle larvae. I never managed to do so. This was the technique I used. I didn't dig up many because it's pretty invasive and hard work, really. So what I do is put a bit of pliable grass down the burrow and then excavate around this. But you've got to dig a fair way down. I was down about 30 centimetres, and this was an Andrena nitida burrow. before I found the first nest cell with a pollen ball there. No sign of any oil beetle triangulins. And the other nest cells maybe even deeper than that. So they can go maybe down to about 50 centimeters down, and they'll have various offshoots and little cells built in the offshoots of the main tunnel. So, I tried, but it was almost impossible to locate. Some people have reared triangulins by making bee bread using honeybee pollen and mixing it with some nectar and a little bit of honey, and just mixing it up and making your own bee bread and putting the triangulins onto this. It's a very difficult thing to do to get the humidity right. I found one, and also I'm very busy that time of year, so I tend to be out in the field. So you need to sort of dedicate a bit of time really to do this, and actually have a lab. It's probably better, if it was done in a university lab where you could control the conditions. But did have a go putting triangulin larvae in on the bee bread. Some of them started to feed, most of them just ignored it actually. Anne Halpin, who did some work, who was working for Bug Life at the time, was more successful than me, and she did get one to go from the triangulin stage to the next larval stage, where it's more like a sort of maggot which feeds on the bee bread. So she was actually successful in getting it to this, but again, it died shortly after this because it's very difficult to keep that food fresh and stop mold encroaching in on it. So it was impossible to rear it. But I think it has been done, but I think you need to have a specialist lab really if you're going to attempt to do this. But it would be an interesting thing to do, and also to try and do some experiments looking at interactions between, say, nomad cuckoo bee larvae and oil beetle larvae, see which would be more dominant in the nest, and bee fly larvae as well, and just see what would happen, because there's obviously quite a bit of competition for these bee nests between these different parasitoids. So that's the end of the main part of the talk on oil beetles, but there's still a lot to learn about these fascinating beetles. As I said, there's a lot of their life history happens underground, so it's quite difficult to tease out how to discover what are the hosts of these beetles, because they obviously rely on solitary bees. I mean, one of the things I did was the nearest way to actually find out what were probably the hosts of certainly the violet and the black oil beetle was to go out on those very first days in spring and find the oil beetles when they just first emerged, so you could see that their abdomens weren't extended at all, so you knew they'd just come out of the bee nest. So mark that spot, so whatever host bee is nesting in that area. Then I'd wait until a few months later when the triangulin larvae were active, and then at that time I'd go and sit by the places where I'd seen the adults emerge, and then just see which species of bee were nesting there. And you just sit there for a while, and then various species of bee would come in. So I identify things like Andrena cineraria, which is almost certainly the host of the black oil beetle at Bulbury Down and other places along the South Devon Coast, because there always seem to be large numbers of them where I found the adult black oil beetles earlier in the year. But again, you need to dig up the nest to actually find the oil beetle larva in there to prove this. So there's various bits of information, apart from the books I mentioned earlier. If you have a look on my website, which is johnwalters.co.uk, I've got a special page on oil beetles with lots of information on there about oil beetles. So I've got that identification guide and various references as well, some papers that have been written on them, and links to videos as well if you'd like to have a look at these beetles in action. There's various videos on my YouTube channels, which also are available through the homepage of my website. Stephen Falk, no doubt many of you will know Stephen, and he's got an excellent Flickr site for all sorts of insects, particularly his bee and hoverfly Flickr sites are really top rate, and they're sort of first port of call really if you're getting into identifying those groups of insects. And he's got a selection of pictures of oil beetles as well. There's the Bug Life website, and there's information. I think you can download the identification guide from there and also get advice on recording oil beetles. There's the Oil Beetle recording scheme, which is accessible through the website listed at the bottom there, coleoptera.org.uk. And that will direct you, if you want to record oil beetles, directly to iRecord, and then you can import the records there. So when you're out recording, I know most of you will be familiar with this, the important information you need is where you are, so a grid reference, either an eight-figure grid reference would be ideal, and then the date, place name, and details on the habitat as well. But you can record all that, plus photos as well, which will help with identification. And when you're taking photos of oil beetles, particularly the two tricky ones, try and get a close-up shot of that thorax, the thorax area on the beetle. If you can get a good photograph of that area, that usually will enable you to identify the beetle fairly easily. There's also a Twitter site, Oil Beetles UK, so you can tag them and ask them questions about oil beetle. You've taken photos of oil beetles, you're not quite sure what they are, tag them in on there. Or if you've just got any interesting sightings of oil beetles, that's always useful to put them on there. And as I said, my website, johnwalters.co.uk. Well, thank you very much for listening, and I hope you've enjoyed the talk. And as I said, I'll be happy to answer any questions on oil beetles in a moment. So I'll hand you back to Hayley for the minute.
Lovely, thank you ever so much, John. I think everyone will agree that that talk was absolutely fascinating, and yeah, you've done some excellent work on your kind of study of oil beetles. So thank you very much. Please put any questions for John in the chat. We don't have any specific questions right now, John, but there is something to note, but I think we'll come to that at the end of the Q&A, because that's related to our field visit tomorrow night. Okay. But just a few thoughts from me. I think yeah, often people don't realise that these kind of coastal paths and paths through fields are actually really important habitat for solitary bees and oil beetles and other associated parasites. Presumably the oil beetles would also find their way into some of those vertical nests in soft rock cliffs, like at Prawl Point. Yeah. Have you come across that?
Well, I haven't seen them. I mean, I haven't dug out any of those nests,
No.
but I no doubt they will use them, because you find them in close to those populations where you've got solitary bees nesting in vertical cliffs. I no doubt they will be in some of those nests, but actually proving it is a very difficult thing. But certainly at places like Prawl and Wembury, particularly where you've got a vertical cliff and then you've got a nice bit of coastal vegetation along the top of the coast path, you'll get lots of oil beetles there. So they must be using those bees which are nesting in the vertical cliff, as well as others which are nesting in the banks. But as I say, it's pretty impossible to prove this. One thing I forgot to mention is one thing oil beetles do need is some sort of vegetation. So they need solitary bees, areas where solitary bees nest. But if that area is sort of barren and area sort of very short vegetation, and there's nowhere for the oil beetles to hide, then it doesn't really provide a good habitat for them. They need sort of grass tussocks, this sort of thing, particularly the winter active ones, the Mediterranean and rugged oil beetles. They need to hide away during the daytime, and the others as well, which are active in the spring, because the weather's not always pleasant in the spring. So they can emerge in February, then it can snow, so they have to go and hide away. So they do need some tussocky vegetation close to where the bee nests are as well, to provide a habitat for them.
Okay. So you mentioned a couple of sites in South Devon. Are there any areas, sites potentially in our hotspots that you think could be oil beetle sites?
Oh yeah, sure. Yeah, I mean, the thing is, going out at night looking for these things, in the winter is quite hard work, especially going out on spec. So I mean, I long suspected that they might be at Prawl, but I just never been down there. But then a chap called Dave Grundy who's into moth trapping, was doing some moth trapping down there, and one crawled into his moth trap. So as soon as I got wind of that, I went down there and found them immediately. But there's bound to be other areas. So some of the sites you mentioned, say Berry Head. I mean, in fact, at Berry Head, because it's calcareous, there could potentially be rugged oil beetle there, which at the moment is unknown in Devon. So it would be worth searching there. But there's anywhere really along the coast path in the life on the edge area it has potential. Wherever there are solitary bees, there's very likely to be populations of, well, there are known populations of black oil beetles, and there's also very likely to be some populations of Mediterranean oil beetle, which is just currently unknown. And I've earmarked a few sites, and I'll actually try and get out and have a look at those this winter, actually. And so if anyone comes along tomorrow and is interested in doing that, we can go and search some other sites if they're interested.
Yeah, no, that sounds really good. Yeah, I think it's really positive that Life on the Edge could potentially really help to expand our kind of knowledge of the, oil beetle species distribution in South Devon. If people are, going out and recording via iRecord and uploading that data to the National Recording Scheme, that's exciting.
Yeah, and there's potential to find, I mean, the short-necked oil beetle, as I said, is only found at Bulbury Down at the moment, but again, it could occur at other sites, and it's having people who are familiar with the beetles and also, just looking really. So the more pairs of eyes out there, the more chance there is of locating it. But I wouldn't be surprised if that occurs somewhere else as well in the Life on the Edge area.
Yeah. Okay. And so actually, just thinking about tomorrow, it's worth people downloading iRecord probably in advance, isn't it? Because then everyone could have a go at uploading records to iRecord. There won't be any signal there, but you can complete the upload when you get back.
Yeah, you can do. Or I mean, I tend to record things myself when I get home. I love to do it, but if you want to do that, just familiarise yourself with iRecord. It's very easy to join and to use, and it's very user-friendly and very useful system. And also your records will be verified as well, so adding photographs is very useful. And I think Liam Olds, who works for Bug Life in Wales, he does the verification on the iRecord of the oil beetle records.
So you listed a number of websites and ID guides, Twitter, etc. So I'll send links out in an email, so everyone's got those, and we can bring along some ID guides for tomorrow night. Sorry.
We will find some other beetles as well. So I've done a little field guide to beetles you find at night, or things I come across. So as well as hopefully Mediterranean oil beetles, but you'll find other species of beetle which are active, particularly on the coast. A lot of them are active right through the winter because it's so mild there. And we'll find other species as well, various ground beetles and devil's coach horse and leaf beetles as well. So I've put in a few of those other species, which are easy to identify in the field, so we'll be able to record those as well.
Okay, lovely. Thanks very much, John. Now I'm just going to stop recording, and then we can just quickly discuss the thing that Emma's brought to our attention, which is the road closure at Frogmore. So thank you ever so much, John. I'm going to stop recording now.